Hello everyone. Today I am starting with first lecture. In this lecture I will be discussing the vector field, scalar field, reference point and a little bit about the coplanar vectors. Okay. So as of now these topics are known to everybody, I think. Okay. But still I want to explain about these things. Okay, because I will get some interest thing with this facts and topic. Okay, so suppose as we know that the vector, what is vector? Vector is a quantity, physical quantity, which will having magnitude and it will be having a direction in space. Okay, vector is having magnitude and also will having one direction in space. Okay, so what these things? The direction, the vectors we heard about this vector term. So obviously first thing comes in our mind the force, the velocity. Okay, these things are the vectors only. Okay, so if vectors are, suppose vectors presenting v and this gap, okay, line 2ax plus 3ay minus 4az. What are these things? These are the nothing but these are the components of vector. Okay, this 2ax, 3ay and minus 4az. Okay, suppose if you see this vector is presenting with magnitude and a proper direction. So if you see that the direction, so if direction magnitude is this, suppose for a particular vector f 2x 3y minus 4, this particular vector, what is the magnitude? Magnitude is under root of 2 square plus 3 square plus minus 4y square. Okay, so that means 16. So this magnitude is under root 29. Okay, now the term is the direction. What would be the direction? So if direction is there, then there is a vector, means term is there, unit vector. So unit vector is what? So in the term itself, it is behind that. Unit means what? One. So this one also one vector. Okay, so the presentation of that, the unit vector, so its magnitude will be magnitude 1, but in that direction this vector is increasing. Any vector is increasing. So for this the vector, this vector also will having some one magnitude and the direction is in that direction the vector is increasing. Okay, so for this vector, what is, for this vector we can present as a, this is a magnitude and this as a unit vector. Okay, so any vector we can present as a magnitude with unit vector. So how this unit vector we can present? So unit vector, obviously it will be having magnitude of that, magnitude will be 1 and the direction, and for this vector the direction, in that direction the vector is increasing. Okay, so these things will represent as a unit vector for each and every vector. For this particular vector, if you see, there are 3 components basically in 3 dimension. In 3 dimension, what the dimensions? In x, in the x direction, this fx component, in the y direction this fy component, and z direction fz component. If we see in this 2x plus 3y minus 4z. Okay, 2x x in the x direction, 3 and y direction minus az. So now if you see in the 3 dimension, if you see in this coordinate, okay, suppose let's take as in this way I am taking as a positive x, and this way I am taking as a negative x, and this way I am taking as a positive y, and here in this way negative, and in this way z negative, in this way z positive. So this is the configuration of 3 dimension. Okay, so in this way we can present. So here one point will be there. This point is the known as reference point or origin of this coordinate. So what is that origin or reference point, and why this origin is required? So one practical example is that there is, if there is no origin, means where would somewhere any point is there. Okay, so how it will present? We need one point, with that respect we can relate with this. Okay, otherwise no meaning of that. Okay, means there will be no existence in physics. Yeah, this practical mathematical things. Okay, so we should take as a reference. So reference point here I am taking as a this would be name as the origin point or reference point. So why this is required? Origin, why it is required? So origin is required because we have to measure the position or motion or any particular thing we have to measure. Okay, suppose particular thing means, suppose here origin is there, this point origin we can present as a, obviously how we can present as a origin, this point. Okay, so this reference point as a system of geometric axis is relation to which the measurement of position and motion. Okay, so reference point and geometrical position point used to be defined the location of another point. Means what? अगर कोई भी पॉइंट यहाँ पे होगा या जिधर भी होगा, ठीक है, with respect to that point we can define the position. Okay, so that's why the reference point, yeah, reference frame is required. Means otherwise we can't define any point, anything. Okay, clear? So here is the, for this vector presentation we are discussing about this. So suppose any force is about for here this force is 2x plus 3y minus 4az. Okay, so az x in this direction, ax, in this direction ay, and in this direction az. Okay, with respect to that point. Okay, so now what will be the direction for this force? So here the force is given as a 2 unit, as I know that these are the vector component and the unit vector along x axis, and ax along x axis, ay along y axis, and aaz along z axis. Okay, so now here 2 is the magnitude along x axis, 3 is the magnitude along y axis, but 4 is the magnitude along which? In reverse direction of z axis, negative z axis. So what will be the configuration of force? So in this way 3, and this way what? In this way what? Sorry, my 4, 3, 2, 3 minus 4. This one is 4. This one 4. This one be this one 2. So this 3 and 3 this 4, y and along this 4. Okay. So now this component is presenting in the negative direction of Az, but magnitude is 4 only. Okay. Magnitude, we know the magnitude is positive quantity. Okay. So it's depending on the direction, either Ax or Ax minus, in the positive direction of x or in the negative direction of y. In the positive direction of x or negative direction of x. So these things is come into mind. Okay. So these are the configuration. Okay. So now this vector, this is vector. Okay. And for the unit vector, the magnitude obviously 1 and the direction will be that vector, particular vector increasing in that way. Okay. In which direction is increasing. That is the unit vector. Clear? Now the vector field. What is the vector field? Example. Suppose vector, if we explain this vector field. Vector field is nothing but a function. A function is which required because if it's changing the region and changing the position, then the its magnitude and its direction will be changing. Okay. Suppose I am taking an example to explain this concept of this example. Vector field. What is the, why this vector field is required? And vector, what are the vector field basically? Okay. Firstly see that. Suppose one particle is there. Suppose objective is that we have to move that particle. Okay. Suppose I am taking this. This is a circular path on this plane. What is this plane? This plane is z equal to 0 plane or xy plane. This is known as xy plane. Clear? So z equal to 0 or xy plane. Suppose anywhere one particular point is there. Okay. Suppose we have to apply some force on that and this and such way that it can traverse the circular path. So how it is possible? So obviously this force here in this way working, and here in this way working, here in this way working, here in this way should work. Otherwise the object will no longer be follow this path. Okay, just understand. Okay, our aim to travel this object on this circular path. Okay, but the force should be like that force also acting in such way that the object travels in this path. Otherwise what? The object may be delocated, maybe here, maybe here, means it will not cover this path. Okay, so that's why what? The field is there. Okay, force field is coming. Okay, force field means that vector field is coming. So vector field of force. Okay, here is required. So if that is there, then we can traverse in this way to move the particle along this circular path. Okay, suppose any example, suppose I am taking this. Okay, one example, suppose this f 2xy ax plus xz ay plus zy az. Okay, now any point at x at f11 to x x1 y1 and z1. What is the value of this? The 2x plus ay plus az. That means what? At that particular point, a magnitude is under root 6, magnitude is this and direction is this, and this is the direction. Clear? Now see that here under root 6 and direction is different. Suppose what? Suppose where will be the point? So it for this for that example it should be 0 because we are taking as n on xy plane, xy plane. So this root 4 and this will be 5 and this y only, okay, and this will be the magnitude, okay, because the xy plane. So here what is the magnitude? Root under root 5, but direction 2x plus this, okay. So suppose at this point what one point will be there. Suppose here is the suppose here I am taking this is 1 1 1 0, okay. So here is working the magnitude with under root 5 some different color under root 5 and direction is somewhat different, okay. And here and for another one suppose I am taking this and here also I am taking this as a 0 because at xy plane, xy plane. So what would be the, this component will be no longer there. Oh sorry, see what is there, function is 2xy z, this and this z will be no longer there because z is 0 varying with z. So this component also be not there, this also be not there, this also be not there, okay. So clearly you can see that this will be the magnitude 4 and this will be the magnitude 4, okay. So see, for this here is the direction, this direction at some that point 1 2 and this direction some here, okay, okay. So the force magnitude also different and the direction also different. So what? So obviously this force will not traverse this path, okay. It will somewhere if forcing on, suppose on this force is acting on this particle, suppose the particle moving in this way and in that location it will be moving in this way, yeah, some different direction, okay. So this is the concept of the vector field. So what are the field we will be studying on this vector field, okay. You will see the vector field when English will come into this electric field, magnetic field. These are the common thing you will be getting, okay, in your curriculum. In this lecture series you will be getting this field. Why this field is there? This is also electric field, also a vector field, okay, and magnetic field also a vector field, okay. Due to this field what is happening? Due to this field what is happening? We will be seeing, okay. Now the point is that the scalar quantity and the scalar field. What is that scalar quantity and this? Vector is having vector quantity and vector field. This before going to jump into this topic, so I want to clear this vector field. So vector field is nothing but it presents as a function, okay. So magnitude and direction of that function, magnitude and direction of that function will change throughout the region. Magnitude and the direction of that function will change throughout the region, okay. Means what? And this region is there, na? Suppose I am taking this region. So what about the region? Okay. Suppose I am taking in this plane. You may take this on this plane. and somewhere different in here in this space in space. Whatever will be the magnetic force function, yeah, whatever will be the vector field, means whatever the requirement of that, okay, in case of electrical machines, in case of power systems, whatever the discussion is there, in case of mechanical body movement, in case of particle movement, okay, so whatever the function is there, you have to design that way, okay, and then you can proceed with that, okay. So this is the thing, we need to design the vector field, okay. And the scalar field, what? Scalar field is nothing but this is the scalar quantity. Quantity is what? The scalar quantity means it will be having only magnitude, okay, nothing else, no direction, okay. The scalar field also it presents as a function. Scalar quantity is a physical quantity, okay, but scalar field it is having a magnitude throughout the region. There throughout the magnitude and as well as direction was for the vector, but in case of scalar field only that throughout the region it will be having magnitude, okay. So suppose in that case we will be starting the energy field, that means potential field, that means potential field, and the scalar quantity, basically what are the scalar quantity? Mass, temperature, length, and the pressure, temperature, these are the scalar quantity, okay. And the one more concept I want to discuss with this, the coplanar vector. What are the coplanar vector? With this, the coplanar means in the same plane, coplanar in the same plane, in the same plane, in the same plane. What is the coplanar vectors? The in the same plane means what? Suppose this kind of plane, okay, and here I am discussing this plane, okay. Suppose here one plane is there, so what this plane, and here one plane is there, and here another plane is there. So this is nothing but what plane? This is z equal to 0 plane, z equal to 0 plane or xy plane, and why this yellow one and this z1, what plane? This one, this plane, what? Z is increasing and this x, so here y equal to 0, so it means xz plane. So suppose anywhere, suppose here I can form one plane, okay, see the plane and another. Somewhere any plane, I am considering this one plane, okay. So what will be the coplanar vector? Suppose here I am, any force is acting, suppose in this direction a vector is acting, okay. So what will be the coplanar vectors operation? So their coplanar we can analyze this coplanar vector with these components. One will be the horizontal component and one will be the vertical, okay. One will be the horizontal component, suppose horizontal component, and this is the vertical component and this is the horizontal component. horizontal component, this will be the vertical component. Okay. Any plane it may be. Suppose in case of in this plane, okay, so in this plane y equal to 0 or exact plane, what will be the, suppose in this plane, suppose one vector is operating in this way. Suppose in this way vector is operating. Okay. So what will be the component? And the component will be in direction of x, y direction, and sorry, in case of in this way z direction, and in this way आपका x direction. Okay. So because it is in x z plane, okay, so there will be x direction and will be z direction. So this will be the whatever, this may be the vertical and it may be the horizontal. If it is horizontal, it will be the vertical component. Okay. So in the coplanar vectors are analyzed with this horizontal component and the vertical component, divided into horizontal component and vertical component. Okay. So these are the things. Okay. So far this lecture we have discussed these things. First we have discussed the vector, what is the vector, and the vector field. Okay. In thoroughly we have discussed with an example. We have discussed the how this vector field is required for your study material. Suppose you are in engineering, you are mechanical engineering, wherever this vector is required as a force or velocity, whatever the term will be coming, so it should be utilized in your way. Okay. So whatever the objectives, you have to solve in that way. Okay. And you have to find in that way. You have to find for a vector in that way. Okay. In scalar field, the scalar things, quantity, it is a simple quantity, temperature, mass, volume, etc., pressure. These are the field. Okay. In the scalar field, in this curriculum, we will be seeing that the potential field is a scalar field, and many more are there. Okay. And the coplanar vector we have discussed, the horizontal component and vertical component will be there with in same plane. Vectors will be in the same plane. With this I am ending up. God bless you. Okay, we'll meet in next lecture. Thank you all.